What happens when you have a third substituent? When then you have an additive effect. You need to look at where would that, the first substituent, one of the substituents, where does it direct? And the other substituent, where does it direct? And sometimes you have additive effects and sometimes you have subtracting effects. So for example, you've got here paranitrotoluene. So a methyl group directs positions ortho and, well, para, but there is already a group in a para position. And the nitro group directs a meta position from itself, which is again these two positions here. So both groups, the methyl group and the nitro group, work together to favor this position here. Oh, well, the alternative one, this one, the compound would be identical. So in this case, you have an example of two substituents that work together favoring a particular position in the ring. So that is the compound that is formed exclusively. Sometimes you have substituents that have opposite effects. And then you end up, either the most powerful activating group will determine the principal outcome, and most likely you have a mixture of products. The other one will still have some influence. So for example, a hydroxyl group favors ortho and para positions to itself. The para position is already occupied, so it can only be these two. And the methyl group also favors ortho and para positions to itself. The para position is occupied, so it will favor the ortho positions. So you end up that all the positions are favored. The hydroxyl group is stronger than the methyl group to direct. So you have as the major product this substituent in which the bromo is in an ortho, this compound in which the bromo is an ortho position to the hydroxyl group. So, but you would have also a certain amount of the other ones, of the substituent when where the bromine atom enters in this carbon, because the methyl group is also playing an effect. When you have a meta-substituted compound, you cannot get, when you're trying to make a substituent compound with three substituents and you want them adjacent in three adjacent carbons, you need to be careful what is your starting reagent. So for example, when you are using this, meta-chlorotoluene, and if you wanted to add, let's say, another chlorine atom, the positions favored by all the substituents would be this one and this one and this one. They are all ortho and para positions. However, this one will not form. There are already two substituents here. The third one will not enter. So to make a tri-substituted benzene in which the three substituents are in three adjacent carbons, you cannot start with the with a meta compound. Sorry, you are better off, or what you'd have to do is start with the ortho compound. So for example, in this one you have the methyl group and the nitro group in an ortho adjacent to each other, and you can then form both compounds of substitution. If you add another nitro group, you get both compounds, the one in which the nitro group is in the adjacent position to the methyl group and the other one in which it would be in an opposite position, because both the methyl group and the nitro group will favor this position. But the bottom line is that you are able of putting these three substituents adjacent to each other, and you will not be able to do it if you are starting with a meta substituted benzene. You can have nucleophilic aromatic substitutions with benzene, and you can have them when you have a halogen in the structure, because a halide ion is a good leaving group. So if you have a benzene ring with a halogen in the structure, an aryl halide, and you have a substituent in the ortho or para position, which is electron withdrawing, so a nitro group or a carbonyl group of some description, for example, or of ammonium ion, then you can have a nucleophilic aromatic substitution and an attack of a nucleophile onto this this carbon attached to the, so for example here the OH attacks the carbon of the where the chlorine atom is, and the chlorine atom is eliminated as a halide, as a chloride. And as you can see, you can form the ortho compound, in which they're both adjacent, or the para compound, in which but you cannot have a meta compound, and that is because when you are doing this intermediate is a negative an anion, a carbanion. So if you look at this, they have this negative charge. So the nitro group helps stabilize that intermediate by withdrawing electrons, so helping stabilize that negative charge. But here, in this meta intermediate, you have the negative charge is not in the carbon adjacent to the nitro group, so there's nothing stabilizing that carbanion, and it doesn't form. So you end up with you can do substitutions you can do nucleophilic aromatic substitutions if you have a halogen which is in ortho position or in para position to an electron withdrawing substituent, a nitro group or a carbonyl group, for example. So this is all for now. I hope this was useful. And again, if you have any questions, please email me or post in the discussion board for the module. And thank you very much for watching.